Hi folks, today we're going to talk about special products. And special products are pretty easy if you've already done section 8.3, right? So special products, so looking at multiplying, right? That's what product means, to multiply. And you are going to be multiplying, if I can spell correctly, you're going to be multiplying two binomials, right? So if you were to square something, it has to be a binomial, so two terms. Let's say we have, I have my examples right here that I posted. If we were going to multiply 3m plus 4 by itself, that's what squaring is, right? So we want to rewrite it side by side. And so now we get something that looks very much like what we studied in the last section, which is multiplying binomials. And so you can rely on your FOIL method, which is that double distribution, right? First, outer, inner, and last. So when you look at the first times the first, first times the first, that would be 9m squared. The outer times the outer would be 12m. The inner times the inner is also 12m. And the last times the last is 16. So this FOIL method is kind of coming back at us again, right? We're doing the same thing. It just originates or starts with something that is being squared. Okay? I would caution you to not bring the exponent in. You can't do that for a sum or a difference. You could if it was a product or a quotient, like we learned in chapter 7. But you cannot bring in the exponent here, right? You've got to write it side by side, and you've got to FOIL that out or double distribute, right? You're distributing this term times both and this term times both, okay? Now you're not going to stop here, because when you multiply that out, as we noticed in the last section, you're able to do some combining of like terms. And so what happens is that the outer and the inner, all right, the outer and the inner terms are able to be simplified. So 9m squared plus 24m plus 60. Okay, and that will be my final answer. It's a trinomial. So we're noticing here that when we square a binomial, we get a trinomial. Now, sometimes when you're squaring a binomial, you're not going to have a positive there, you're going to have a minus. You're going to have a difference, right? So again, we're still multiplying, and these are special products because they start with squaring a binomial, so you're doing the same multiplication. So you get kind of deja vu effect here, okay? So let's say we've got 4x minus 7 quantity squared is equal to 4x minus 7 times 4x minus 7. That's what squaring means, multiplying something by itself. And so now we're just going to do, once again, that FOIL method, all right? Some teachers don't like to use that mnemonic device. They want to emphasize that it's distribution. You're using the distributive property. But like always, as you know, I say use the method that works for you. And if this is a strategy, if that's something that helps you remember to get in all the products, then use it. Okay? So first, 16x squared. Outer, negative 28x. Inner, negative 28x. Last, positive 49. Okay, so notice once again you get the same outer and inner when you're squaring, but this time they're both minus. When you square a difference, you do get a trinomial, but the middle term of the trinomial is always minus because you have a negative plus a negative. So this would be equal to, right? The first and the last will not change, but the middle term is going to be minus 56x. So that's another special product. The last special product I want to talk about is something called a conjugate. Conjugate. So often in mathematics, we know we have these words that, might mean something different if you're not in mathematics. It could mean other things. So I'm sure you've heard of the word conjugate when you're looking at your world language class and conjugating verbs, right? A conjugate in math means something very different, okay? A conjugate is basically the same terms but with opposite signs, okay? So this term conjugates, right? A plus B and A minus B are conjugates. All right, it could be anything. It could be x plus 3, x minus 3. 5y minus 7, 5y plus 7. Okay, so these two things have to be the same. These two things have to be the same. The interesting thing is what happens when you multiply conjugates. So here's an example of conjugates. And let's see what happens when we multiply them. Okay, we've got 2x plus 5 times 2x minus 5. So these are conjugates because they are the same term, right? 5 and 5, these match up perfectly, these match up perfectly. The only difference is you've got a plus here and you've got a minus here, right? So let's see what happens when we multiply conjugates. You've got your first. Your first product would be 2x times 2x, which is 4x squared. Your outer term is going to be 2x times negative 5, or negative 10x. Your inner will be 5 times 2x. And your last would be 5 times negative 5, which is negative 25. Or minus 25. Okay. And let's notice what happens when we simplify here now. When we simplify a product that is a product of conjugates, when you add the outer and the inner, they're going to cancel out every time for conjugates. So we're just going to end up with 4x squared minus 25. These are going to cancel out for us. Whoops. All right. So when you multiply conjugates, you get a binomial, which is different from the other products that we've seen. I think you had a couple of those in the homework from last week. They kind of just threw those in there. So, you might get a little suspicious as to what was going on and then kind of investigate, right? If we were in school, I would have done like a whole investigative kind of process there. But this is what happens when you multiply conjugates. You actually just get a difference of squares. So this is going to be a squared minus b squared because the outer and the inner are going to cancel out for us. All right, folks, so try those problems this week on section 8.4, special products, and please do the Delta Math review problems that I posted. I have, I think, 7 radical reviews and 3 exponents. So just 10 problems on Delta Math to keep those skills sharp. You're doing a great job out there. Keep on working as hard as you are, persevere, and always do your best. Right, take care, folks. Have a good day.